Chapter 4.2 Particle Vibrations and Wave Motion. From the discussions of last chapter, you should have noticed that wave motion is formed by a series of particle vibrations. So, how are the particle vibrations and wave motion related? And how are the vibrations of different particles related? First, let's take a look at Mexican wave before we move on. Mexican wave is also called stadium wave. We know clearly that the people do not travel from one place to another, but each people only stand up and sits down one by one on their own seat. A wave is similarly formed when particles vibrate individually, one by one, in sequence. 1. Describing particle vibrations. Let's look at the vibrations of individual particle. For transverse and longitudinal waves, and even traveling or stationary waves, particles vibrate about their respective home position called equilibrium position. Let's learn some basics about particle vibrations. When a particle is not disturbed by the wave, it is at its own equilibrium position. When the particle is set into vibration by the wave, it vibrates about its own equilibrium position. It has different displacement at different times. So for this red particle, it first of all moves up and down to the very bottom and back to the equilibrium position. A. Amplitude. It is the magnitude of the maximum displacement of a particle from its equilibrium position, as shown on the left. It is a length measured in meters. B. Period. It is the time for the complete vibration, measured in seconds. Regardless of the starting point, the period of all particle vibrations in a wave are always the same. C. Frequency. It is the number of vibrations completed in 1 second. For example, a particle vibrates with a period of 0.5 seconds. Then it may complete 2 complete vibrations in 1 second. And hence the frequency is 2 Hz, where Hz is the unit for frequency, which represents per second. Thus, we have frequency equals 1 over t for frequency f and period t of particle vibration. Example 1. Describing particle vibration. The peak-to-peak displacement of a particle is 0.1 meter, so the amplitude is 0.05 meters, which is 5 cm. And for period and frequency, they are easily calculated. Now, try check point 2 below.